Okay, so we're in 2.7, graphing techniques, and we're going to do stretching and shrinking. Okay, so vertical, that means up and down. We're going to do a vertical shrink and a vertical stretch. So if I look at this x squared, I know it's a parabola, it's a happy face, okay, and I'm going to put a half in front of it. Okay, so first, if I make a table of values for my parabola, if I put a 1 in there, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. If I graph it, it's the purple one here, okay, x squared, the purple one. So now it says, if I put a half in front of the x squared, what happens? Well, it says, please take a half of whatever this is. So if I put 1 in this, 1 squared is 1. What's half of 1? A half. If I put a 2 in here, 2 squared is 4. What's half of 4? 2. What's half of 4? 2. If I put a 3 in here, 3 squared is 9. What's half of 9? 4.5. So I'm just taking half of these. Okay. Now if I graph the green one, okay, it's like this. Okay. Now let's look at the blue one. Whatever x squared is here, it says multiply it by 2. So if I put a 1 into here, 1 squared is 1, 2 times 1 is 2. If I put a 2 into here, 2 squared is 4, 2 times 4, 8. If I put a 3 in, 3 squared is 9, 2 times 9 is 18. Okay, so now if I graph the blue one, it looks like this, okay? But now we have to understand if it's a vertical shrink or a vertical stretch. So what I like to do is I like to just look at one set of points and see what happened. So my original, my parent function is 2, 4 here, okay? Now the green one, it went 2, 2. So this point was moved down. Okay, so if I'm going up and down, that means vertical. And because it was moved down, that means it's shrinking. It's getting smaller. Okay, so this is a vertical shrink. So when I put a half in front of something that's smaller than 1, it's going to be a vertical shrink. Now let's look at the blue one. If I graph that, it's now 2, 8. So this point moved up. It was 4 here on the y-axis. Now on the y-axis it's 8. So it moved up, which is a vertical change. And because it's moving up, I'm stretching each point up. So this becomes a vertical stretch. So you can see the y values change. So when y values change, it's either going to make it stretch taller or shrink vertically, because the y value, the y-axis here is up and down. Okay, so now let's look at x and horizontal. So now what we're going to do is look at the parent function. Same thing, it's here. I graphed it, the purple one. Okay, but now it's going to be a horizontal shrink and a horizontal stretch. Okay, so if I want to, these are going to stay the same. I know the x's are going to change. So here, just a second, someone's at my door. So my y values are going to stay the same. So I need to put an x value in here that's going to make it 1. So 2 times, well, I have to make it, let's do this one first, okay? So I need to put a value in here such that it makes a 4 inside, so the answer will be 16. So 2 times what is 4? Well, 2 times 2 is 4. So I put a 2 here. Because 2 times 2 is 4, and I square it, that'll be 16. Now here, I can look. 2 times what is 3? Well, 1.5. So if I go 2 times 1.5, that will make it 3. And what's 3 squared? 9. 2 times what is 2? 2 times 1. So 2 times 1 is 2. That makes 2 squared would be 4. So what happens is, because there's a 2 in here, because this 2 is making everything bigger, my x values have to be smaller to compensate for this, to balance it out. So I have to make my x value smaller, because all of these little small numbers are going to be multiplied by a 2. So because these numbers are smaller, my x values are shrinking. They're getting smaller. And so this is going to be a horizontal shrink, because x, my x-axis, okay, my x-axis is a horizontal line. So if I graph this, it's the blue one here. Okay, let's just look at one point. So let's look at 2, 4. That was my original point. Now the point is 1, 4. So there's my new point, 1, 4. So you can see the x value was 2. Now the x value is 1. So it got smaller. It was 2, now it's 1. So it's shrinking horizontally. So now let's look at putting a half inside the function. So I want to keep my y's the same, and I say, what do I have to put in here to make, let's do the first one, 4. What do I have to put in here to make that 4 so I can get a 16? Well, if I put an 8 in here, what's half of 8? 4. And 4 times 4, 16. So here, what do I have to put in here to make a 6? No, to make a 3. So I have to put a 6 in here. What's half of 6? 3. 3 times 3 is 9. So this half is making everything smaller. So I have to put big numbers into here because this half is making everything small. So I have to use bigger x values to balance out this half in here. So when I graph it, you can see the green line is bigger. Let's look at just this point. So here's 2, 4. Now it's become 4, 4, which is here. So my x value was 2. Now it's increased to 4. So these numbers, these x values are getting bigger, and they're getting bigger horizontally. So it's a horizontal stretch. But it's kind of opposite. You think half is, oh, it's half. It's going to make things shrink. But you have to say, well, what x values do I have to put in here to keep things the same? Well, I have to put bigger x values in here. So it's going to stretch things. So these ones are kind of opposite of what you might think. These ones make sense. You got a half, it makes it small. You got a 2, it makes it bigger. Here, the horizontal is opposite. Okay? So let's look at some examples. So it says, make a table of values and graph each function. Is it a vertical stretch, a vertical shrink, horizontal stretch, or a horizontal shrink? So let's cover this one up here. Now my first equation is just the absolute value. So the absolute value just makes things positive. So I put a negative 5 in there, it equals 5. I put a negative 2 in there, it equals 2. 0, nothing happens. 2, nothing happens. 5 is the same. So let's graph that. Ooh, I did. So I graphed it already. Okay. So now we're going to graph what happens if I put a 2 in front of the absolute value. So let's put a negative 5 in. Well, this negative 5 does what in the absolute value? Makes it positive, so it's really 2 times 5, which equals 10. 2 times negative 2. That makes it 2 times absolute value of negative 2 is positive 2. Okay. 2 times the absolute value of 0. Oh, that's just 2 times 0, which equals 0. 2 times the absolute value of 2. Well, it doesn't do anything. It just goes 2 times 2, which equals 4. 2 times the absolute value of 5. Okay, so you can see what we've done is we've just multiplied 2 by all of these numbers. Okay, so let's see what happens. So how can we get our points? Let's cover this up. My point will be negative 5, 10, negative 2, 4, 0, 0, 2, 4. I'm just taking this number and this number, and 5 and 10. So let's graph it. Negative 5 and 10, and then negative 2 and 4, 0, 0. So now it does this. Okay, but it's hard for me to tell what's happening looking at all the points. So I'm just going to look at one point. So let's look at this one. It was negative 2, 2. So let's find negative 2, 2 here. So that is this original point. Now let's look at the new point. Oh, you can't see it. I'll write it up here. Negative 2, 4. So now it became negative 2, 4. So you can see that the point moved up. So up and down means horizontal. No, I mean, it doesn't mean horizontal, it means vertical. Okay, and because it's moving up, it's stretching it. Okay, so let's move to the next example. So if you look here, the parent function, the absolute value, is exactly the same as down here. So let's just copy the answers in, so we don't have to do it again. And I graphed it already, and this is what the function looks like. But now we're going to put a half in front. So when oh, whoops, it should not be an 8 here. It should be a negative, negative. Okay, we can't copy it down because I changed the numbers. Let's just do it again. So let's make it positive. I put an 8, negative 8 in, it makes it positive. I put a negative 4 in, it makes it positive. And it does nothing with the positive numbers or 0. So now if I graph it, it looks like this. But now it says, whatever you put in, take half. So if I put the negative in, let's cover that up. It's going to be a half. So this is really a half. This absolute value of the negative 8 makes it 8. Half of 8 is 4. Okay, so it's really just going to take a half of whatever is here. So a half, we'll put in negative 4. It's going to equal a half of 4, which equals 2. Half, I'm going to put a 0 in. Well, 0, half of 0 is 0. I put a 4 in, positive 4. Nothing happens. It stays positive 4. And if I put an 8 in, it stays 8. So half of 8 equals 4. So you can see I'm just taking a half of these numbers here. So let's graph it. So this is, I'm going to cover that up. So it's the x value is negative 8, and now it's 4. Negative 4, and now it's 2. X is 0, y is 0. And then down here, x is 4, y is 2. Okay, so now I'm going to graph this. Negative 8, 4. Oh, it's right in the middle of that. I'm going to move that over. Okay. Okay, so this is negative 8, 4. Okay. And negative 4, 2. And then 4, 2. And then 8, 4. So now, all right. So in order to understand if it's a vertical or horizontal stretch, let's just look at one set of points. So let's look at this point, negative 4, 4, on my original one. And then my new point, negative 4, 2, here, negative 4, 2. So it moved down, okay? So that's a horizontal, something happening horizontal. not horizontal. Why do I keep saying that today? Vertical, sorry. I think I need a coffee. So that's a vertical change, and it's moving down, so it's shrinking. So every point is moving down. Okay, so it's shrinking vertically. Oh. All right, let's look at the last one. Well, not the last one. I think I have, yep, it's the last one. Okay, so this function is the same as the one above. It's just making everything positive. So I'm going to go positive 2, 1, 0, 1, 2. Now I'm going to put the 2 on the inside. So now, instead of x, I'm going to put the negative 2. So 2 times negative 2, let's make it so you can read that. 2 times negative 2 is negative 4, and then I need to take the absolute value, so that's 4. Okay. Put a 1 in. 2 times negative 1, that's 2 times, that's negative 2. That makes it 2. 2 times 0, and 2 times 1, and 2 times 2. Okay. Oh! Alright. Just a second. If I look, this is exactly, this is the same. This is the same as the one up here. Oops, I can't see. I'm doubling everything. So with the absolute value, okay, let's just draw this. I'm going to make negative 2 and 4, negative 1 and 2, 0, 0, 1, 2, and 2, 4. So let's graph it. Negative 2, 4. If you look, this one is the same as the first one. And this happens with the absolute value of x, because if I have the absolute value of 2x, I can take the 2 out. Okay, what's the absolute value of 2? Well, it's just 2. Okay, so for the absolute value, it's going to be the same. All right, so remember, okay, here we're going to have a vertical stretch. Just look at one set of points and see how it changes. If it goes down, then it's a vertical shrink. If it goes up, it's a vertical stretch. Okay.